We're going to take a look today at direct and inverse variation. The topic is relatively straightforward and simple. We'll go through the steps required to analyze and solve problems using direct and inverse variation. So direct variation, we start with the formula y equals k times x. In this case, k is called the constant of proportionality. It is typically never given in the problem, the statement of the problem, so you have to solve first to find k. Also make note, direct variation implies that as the x's get bigger, the y's get bigger. For the other inverse variation, we'll start with our basic formula, which is y equals k divided by x. You notice here, as the x's get bigger, the y's are going to get smaller. We still have the k value, which is still the constant of proportionality. It's possible to mix these up so you can have more than one in a particular problem, so you could have multiple direct variations, which would be called joint variation. And we'd have combined variation, where we might have direct and inverse variation in a single problem. Let's look at an example. Here we're given that f varies inversely with d squared. And initially, f equals 20 when d equals 5. So we'll set up the equation. In this case, we have f equals k divided by d squared. We'll substitute in the values we have for f and d. So we get 20 equals k over 5 squared. We'll multiply both sides by 5 squared, and we get k equals 20 times 25, or 500. Once we find the k value, we can rewrite the initial equation. So we get f equals 500 divided by d squared. Looking at the second example, this one involves a 30-year mortgage. You're buying a house. We're going to try to calculate the mortgage payment. So when you take out a loan for 30-year mortgage, in this particular case, you'll pay $6.27 for every $1,000 that you borrow. So we'll start out by setting up the equation. So we'll have P for payment equals K, the constant of proportionality, times B. So in this case, you would get $6.27 equals K times 1,000, which is the amount that you would borrow to pay $6.27. Solving for K, divide both sides by 1,000, we get k equals 0.00627. So based on that, our equation is going to be P equals 0.00627B. So that sets up the equation. The next question is, what happens if I borrow $180,000? We'll try to calculate what our payment would be. We'll just substitute in the values that we have. So P equals 0.00627 times B, which in this case is 180,000. We do that and we find out that our payment is going to be $1,128.60. Next problem, the intensity L of light measured in foot candles varies inversely with the square of the distance from the source. Suppose that the intensity of light from the source at a distance of 2 meters is 0.055 foot candle. You need to determine the intensity of the light from the source at a distance of 5 meters. So we have I equals K over D squared. So the intensity is going to vary inversely with the distance squared. We're given that I is 0.055 at a distance of 2 meters, so 0.055 equals K divided by 2 squared. Multiply both sides by 2 squared are 4, and we get K equals 0.22. Rewriting the equation, we get I equals 0.22 divided by D squared. Now we would like to figure out the intensity of the light from the source at a distance of 5 meters. So we'll plug in 5 meters for D. We do that, we get I equals 0.22 divided by 25, or 5 squared. Simplifying that, we get I equals 0.0088 foot candles. The last example we're going to look at involves horsepower, a drive shaft, and diameter. So the horsepower, HP, that a shaft can safely transmit varies jointly with its speed in revolutions per minute, RPM, and the cube of its diameter. If a shaft of a certain material, 2 inches in diameter, can transmit 36 horsepower at 75 RPMs, what diameter must the shaft have in order to transmit 34 horsepower at 70 RPMs? So to set this up, we get, I set H for horsepower equals K, the constant, times S, which is the speed, and D cubed is the cube of the diameter. The initial statement of the problem says we can transmit 36 horsepower at 75 RPMs with a diameter of 2 inches. So we get 36 equals K times 75 times 2 cubed. If we divide both sides by 75 times 2 cubed, we get K equals 0.06. So my equation is H equals 0.06 times S times D. I'm supposed to say D cubed. So 34 equals 0.06 times 70 times D cubed. Here we're trying to calculate the diameter, so we'll solve for D. So divide both sides by 0.06 times 7, and then take the cube root of both sides, and we get D equals 2. So we would need a diameter of 2 inches. So in order to transmit 34 horsepower at 70 RPMs, we would also need a shaft with a diameter of 2 inches.